Good morning. So I want to examine the wash train for our fiber mill and show how it works in a little bit more detail, as well as some of the modifications we've done to the system from when it was running at the last facility. They're not major changes, mostly just control relocation. So we have a 3-tank system. It starts up here, and each tank holds a fair amount of water, and then there's a wringer system with a conveyor belt that moves the wool into the next tank, gets washed again, and gets washed a third time, and then comes out into containers that we can move over that wall over there, where we're going to have drying racks for the cleaned wool. The system can probably most easily be understood as a zone system for heating, similar to what you would find in a concrete floor that's being heated with water. So I've got this roughly set up at the moment from where it was originally established, and these are the pipes from the original system in the original boiler, which we also acquired. This is a oil-fired boiler, and we're going to switch to a gas-fired boiler, propane in our case. So all of the piping here will have to be, this stuff here will have to be reconfigured. And I'm going to salvage off as much as I can of the hardware from the old boiler onto the new one, including the expansion tank. We have if it's required, I'll take the low water cutoff sensor. There's a bubbler for taking the air bubbles out of the water, pressure reducer, a relief valve, this relief valve here. So those things I should be able to take off and reuse. This main circulating pump, I don't think I'll have to use that one because the new boiler comes with one. So hopefully, and it's a similar size, so it should work satisfactory for our system. So in this case, the hot water, is an isolated system or a separate system from the tank water, or the wash water, if you will. So in each tank, there is a coil that the hot water from the boiler circulates through and then goes back to the boiler, and it heats up the wash water. So it comes in here, goes up to the main loop, and then each tank has its own circulating pump. But it's on the outlet side of the hot water system. So the hot water goes into the tank, into the coil, and then it will get pulled back out with the pump. And we have thermostats that control the pumps and monitors the wash water. This is one of the modifications we're going to make. We're going to turn this out here so it faces out away from the tank. That's one of the things that the inspectors would like us to do, is to get all the controls away from the water as best as possible. Now it's a low voltage system, so it's not particularly dangerous, but we need to keep our inspectors happy. So the thermostat triggers the pump, and that pulls out the cooler water and sends it through the main loop, and more fresh hot water gets sent up into the coil, and then each one of these is an air relief, so we can take the air bubbles out of the system here as well and monitor that. So the wash water in the tank is going to vary in temperature from about 145 degrees and below. Sheep wool takes a hotter wash water than something like alpaca or llama, which we'll also be processing. And there'll be a little bit of soap that's put in the wash water. Unicorn soap, the Unicorn company. That seems to be a very popular soap for fiber washing. So the tank is filled quite substantially. There's quite a reserve of water below these screens, and then the fiber sits on top of the screens and gets is gently agitated by a circulating pump that circulates the wash water in the tank itself, something like a jacuzzi cycle. But we don't want it we don't want the fiber churning around in the whole tank. First, we don't want it tangling up in the coil, but also we don't want really to agitate the fiber, because it's just going to mat up and felt if we do that. So it just sits here and just gets gently agitated with water flowing through it on the surface. And it doesn't stay in here very long, 6 minutes, 10 minutes in the bath. And then it comes here and it gets shoved into the wringer. And the wringer is quite, has a quite substantial force on it. I'll show you all that on the other side. The excess water that's wrung out of the fiber goes into this tank here, and then we can recover that, and it goes back into it gets pumped back into the wash tank. Because we don't need to drain this like every day. It could be in the wash water could be there for a week. It depends on how dirty the fiber is that we're processing at any one time. But certainly we won't have to recycle or drain the water every day. So in this case, the first stage gets dumped into the second tank, it's washed again, wrung, and into a third tank. So these tanks and the whole setup itself is, they're identical systems. Then, and this area here, this is a gear-reduced motor that drives the wringer, and we'll be putting a safety cage over the gears. And then on this side, we'll probably put a bump rail in to keep people away from the main circulating pipes, which will be, well, I'm thinking about 160 degrees water temperature cycling through there. And once I have it all plumbed in, I'll insulate all these pipes to keep the heat loss down to a minimum. The black pipe that you see down here, that's just ABS pipe, and that's hooked to each tank, and that's used for draining the tanks when the water gets too dirty to be used. And down at this end, we have a quick coupling here, and I have a flexible hose, just like a fire hose, that gets hooked in there, and it gets drained down to the far end of the building where we have a floor drain. This hose here, this is PEX A. It's a 1-inch line, and it's for the fresh water, cold water that's going to come in to feed the boiler and fill the tanks. This panel, this piece of plywood, I'm going to use to organize the plumbing up there. So a lot of this stuff is going to get arranged up there. Then we've had to rewire and rearrange the wiring. In its previous location, everything worked just fine the way it was, but in this location, we needed to shift the wires over to the other side. A lot of the wires, and some of the wires weren't long enough, so we had to replace those. On this side, we have the low voltage wire from the thermostat comes out, and we have the power cable for these motors for the ringers. They go over to the other side. The power to these little pumps, they go over here to where the plumbing is going to be, because we have on the original boiler we had these switches here. The thermostats were connected to this, and then the power was sent out to the pumps from the circulating pumps from here. Now, I don't think I'm going to need to use these. I might have to, but we'll see. The new boiler has a 3-zone capability built into the boiler. So since this is 3 tanks, it's 3 zones, and it should be able to accommodate this system and the 3 thermostats directly from the new boiler. So I won't have to use these. We'll see. If I have to, I can move these over as well. So we have this side taken care of. These, the circulating pumps, the cabling for that. Some of the cabling isn't long enough, so we'll have to put in new cables, but the long cable from there can be shifted to this pump and then used on the panel. Then this is the working side, and we've put a platform in that raises us up a little bit, so it just gives better access up here for the tanks themselves. And with the ringers, they have a speed control, on-off switch, and a speed control. They were on here, and the inspectors didn't like that being so close to the water. So we've shifted them over here. They're still readily accessible, readily visible, and we'll be able to quickly get to them from there. So it's not a big inconvenience. But again, the cabling from here wasn't long enough, because what we did was we passed the cable underneath the platform and then up, so we had to put new wiring in for that. Below here, so down here, I wanted to show you these pumps here. These are circulating pumps, And I showed you these yellow plastic tanks. Now this takes the water from the ringers and preserves it here. And we have a, let's see where I got, we have a drain here. And there is a pipe that goes into the bottom of the tank here, and another pipe that goes into the tank there, and a whole series of valves. And this is a circulating pump that will run continuously to cycle the water in the tank, agitate the water, I guess. So think of this like a jacuzzi pump. But we'll also be able to, with these controls, take the water from the plastic tank, the wastewater from the ringers. We'll be able to pump that into the back into the tank itself. But these pumps will run continuously and cycle the water in the wash tank. And we've got the switch for that over here, because it was up attached to the tank as well, but we want it down away from the water. The ringers themselves excuse me, have a these are a low profile hydraulic jack, and it's run by a combination of hydraulic pressure and nitrogen, because we want about 1,600 pounds of pressure on those, and the hydraulic jack won't go that high all by itself. And so here's the controller and the reservoir for where we can hook in our tank of nitrogen, so we can boost the pressure from there. This hose also goes to the these jacuzzi pumps, and we can introduce water or pump water out from there. But mostly with the for draining the tanks, it's a gravity drain from here. Our electricians did a nice job of organizing all the cabling and rewiring some of it and tidying it all up. So we have the majority of our controls on the railing. And they brought power over in a single cable, so this is a 10-strand power cable that will accommodate everything that we need here, plus any power that we need over here for the boiler. And then this was just a convenient spot. This is a controller, variable speed controller to run the opener. We'll use the opener to shred the fiber once it's dried after the washing. So there's a brief update on the wash train and the modifications we've made, and I'll do another one when we have it full of water and running. My next step is to put everything together, get the water system and the boiler hooked up, all the plumbing, and then test all the lines to make sure nothing leaks, and then we should be able to turn it on from there. More to follow.